Mr. Cowan here to help you with the beginnings of geometry and measurement. So, kind of in the textbook, kind of not. We're going to combine several things and talk perimeter and area. If you had this assignment in the near past, go ahead and check it. Otherwise, let's carry on. All right, folks. Goal for today? I would say it's twofold. Action word is fine, but what are we finding? We are finding the perimeter and area of two-dimensional figures. Now, take a walk down memory lane. You certainly identified two and three-dimensional figures, whether you know the difference between a square, rectangle, trapezoid, etc., into three-dimensional figures, cube, rectangular prisms, triangular pyramids, etc. And I would also argue you've looked at the properties of these figures. How many faces, how many edges, how many vertices. So now we step up into actually measuring parts of those figures. For instance, finding perimeter, finding area. And of course, eventually you'll move into 3D figures, finding surface area of cylinders. How much metal would it take to make that can? Or to find volume of three-dimensional figures, like how much air, how many cubes of air, as weird as that sounds, would it take to fill up a volleyball? All right, no matter what the date, no matter what the assignment number, go ahead and pause. I would argue that a lot of this, you could do your work and put your answers straight into your notebook. So pause if you want and come on back when you're ready for some notes. All right, first things first. What are you measuring? This is a weakness that I see in students year after year after year. They don't really know what they're measuring. They don't know what units to attach to the number. They just put, my answer is 30, in which I would say, what, 30 inches, 30 square inches, 30 cube inches? I don't know, Mr. Callen. So let's talk. The first thing you learned how to measure was probably back in first or second grade. You just wanted to learn how long from here to here. That, ladies and gents, is a length. It is one dimensional. And some examples of units. You would say 1 or 2 inches, or 3 centimeters, or 5,000 miles from one continent to another. But notice, there is no number up above. I suppose you could write a 1, being one dimensional, but you don't have to. Nobody expects you to write inches to the first power. On the other hand, if you want to take a table and cover it with newspaper, you need to know what the area of that newspaper is. In other words, because it's two dimensions, it's going to have a length and a width. You're talking square inches. How many square inches of newspaper would it take to cover that table? How many square centimeters of wrapping paper would it take to cover a gift or something? How many square miles would that massive cattle ranch cover of Earth? And then, of course, where we're eventually going to be headed is volume. Now, volume would be three-dimensional if you can follow that pattern. In other words, how many cubic inches of ice could be stuffed inside one freezer? How many cubic miles of rock would make up a volcano? So please know what you're measuring. Is it a one-dimensional length? Is it a two-dimensional area? Or is it a three-dimensional volume? All right, we're going to focus on two-dimensional figures. And let's just review some words. Perimeter, of course, I believe you've learned this in previous years, but perimeter literally means, all right, if I stacked a ruler, lined up rulers, one after another, how many meters would it take to completely enclose this object? Now, the nice part about this, a rectangle, if that edge measures 22 meters long, then so does its opposite edge. And if that edge is 18 meters, then so too is its opposite edge. So what we're going to do is we're going to add 22 and 18 and 22 and 18. Some of you are wise enough to say, Mr. Callen, I once learned to take 2 of the lengths of a rectangle and 2 of the widths of a rectangle. Others of you might notice you could do a little bit of the associative property of addition and put those together and say, oh, Mr. Callen, I know this. 2 40s makes 80. So in this case, the perimeter is 80, and I'd say 80 what? Well, you're just going to say 80 meters, not square meters, not cubic meters. If we line this up with meter sticks, it would take 80 meters to completely enclose this rectangle. On the other hand, what would the area be? So now we're talking not just meters, but how many square meters would it take to completely cover that rectangle? Now, area of a rectangle, you probably already heard this. Write my cursive a little better. No, let's just go with this. Length times width. And if the length is 22 meters and the width is 18 meters, and of course I could argue you could easily switch that. After all, multiplication is commutative. And this rectangle is the same as this rectangle, so you could write 18 by 22. You could write 22 by 18. By the way, I will allow you to use a calculator for this assignment. I believe I'm trying to work with you through measurement, not through multiplication or addition of objects, of numbers. So pull out my trusty calculator. 22 times 18 is going to be 396. And you know what Mr. Cowan's going to say. 396 what? Well, we're talking square meters. Maybe we're talking grass. How many square meters of sod could be laid across that field? All right, onward we go. Let's find the perimeter of this shape. First of all, identify what kind of shape it is, noticing that these are dashed lines. That's not actually a part of the shape. And so if I look carefully at this, I see not one, but I see two pairs of parallel edges, and therefore this is a parallelogram. So we're going to add 14 and 8/10, 14 and 8/10, 6 and 1/10, 6 and 1/10. And yes, you could do it either way, but I'm going to go ahead 14 and 8/10, 6 and 1/10, and then what I'm going to do is I'm just going to double it. So 14 and 6 is 20, 20 and 9/10. If I double 20 and 9/10, I'm going to get 40, 41 and 8/10. What? Well, I'm talking feet. So this is literally if I did have a ruler, and usually rulers are 12 inches, and if I just went all the way around it, it would take me 41 rulers and then another part of a ruler, 41 and 8/10 feet. Area, ladies and gents, is not a length and a width. However, I'd like you to notice something, and maybe your teachers have already talked you through this. If I were to take this little shape, or maybe look at it this way, if I were to cut this out and transport it over here, now you will see a rectangle. A rectangle where one edge is that 6 and 1/10, and the other edge, we no longer need that 14 and 8/10, folks. So area of a parallelogram is the base of that parallelogram times its perpendicular height. So let me just erase that, bring it back to you. We do not any longer need that. We needed that for perimeter, but not for area. So the base of this parallelogram, 6 and 1/10 feet. Height of the parallelogram, 13 and 4/10 feet. Go ahead and pull out our calculator. 6 and 1/10 multiplied by 13 and 4/10. Please use the Decimal Scientific Calculator. This one is exact. And once again, don't forget, what am I ultimately finding here? I'm ultimately finding how many square feet of wallpaper would it take to cover this angled wall, if you will. So I'm going to write feet squared. The other way you can see it is you can see if I would have written feet times feet, of course, makes feet to the second power, feet squared. So if you don't recall that from 6th grade, you might want to write these formulas down. Surely you know length times width, but I hope that you have already seen and are fully proficient with the area of parallelograms, space times height. We'll get to trapezoids this next page. Huh? All right, onward we go. Finding the perimeter of this triangle, again, you see dashed lines, which are not a part of the shape, which means that 3 and 8/10 is not going to be needed for the perimeter. So we're going to add up the lengths of all edges. 8 and 4 is 12, and 4 is 16, and another whole would make 17 precisely. And we're talking 17 kilometers, not square kilometers, not cubic kilometers. Now, let's take another walk down memory lane. How do we find the area of a triangle? What is its formula? Well, no matter what the triangle, can I just point out that a triangle is precisely half of the surrounding rectangle? Even if I did it like this, still half. Even if I cut it through the middle, no matter how you cut it up, an area is going to find the surrounding rectangle, which I'll write base times height, and then take exactly half of that. So if I were to look at this triangle, I notice that a base, I have to look for something perpendicular. I have to look because every height is perpendicular. You don't stand sideways for them to measure your height, right? So look for that right angle. Therefore, I'm going to use 4 and 5/10 as the base length. And the height, it is precisely 3 and 8/10 kilometers tall. Back to the calculator, 1/2 times 4 and 5/10 times 3 and 8/10. 8 and 55/100. This does not carry on, so it is exact. 8 and 55/100. What? Well, we're talking how many squares would it take? This is kilometers, so maybe this is a farm field, a triangular farm field. How many squares would it take to cover that field? Once again, if you did not know that formula, you should probably write it down, put a big old star next to it, box it in. As we finish up number 4, if you'd like, pause. Let's see what you can come up with here. Now, if you noticed, there is one measurement that is not a part of the perimeter, and that is the 8. See, perimeter is the length all the way around, so I'm going to have 15. Add a 9, add a 10. Sorry about that 9 looking a bit sideways, and another 9. 15 and 10 is 25, plus another 18, 35, 45, too far, 43. 43 what? 43 yards. So if we had yardsticks, how many yardsticks would it take to completely surround that figure? And of course, 8 was not on the exterior of the figure. Now, as for a area of a trapezoid, I'm going to take you a little through this. If I took the exact trapezoid and put them right next to each other, what would you notice here? We'll call that the area, the base 1, the base 2. Of course, we've got a height. So if we had an extended, if you will, parallelogram, we're going to add the two bases and call that the length, the base length, multiply by the height. But wait a second, Mr. Callan, we only want one of those shapes, so here comes the half. Now, if you need to rewind, watch that again. Look where the half comes from. Look why we add those two bases up to make the full base of that figure. And of course, we only need one height to find that, and then cut it in half as we already mentioned. So using this formula, 1/2 the sum of the two bases time. For whatever reason, I usually go straight to the height. That just seems easiest for me. Now the two bases are the two edges that are parallel to each other. So in this case, we'll have a sum of 10 and 15. Mind you, you could go in either order, right? Now, of course, you could do this mentally. 15 and 10 making 25. Think about half of 8 is 4. So 4 times 25. I didn't even need a calculator. Sometimes you will, though. All right, 100 what, Mr. Cowan? Well, here we're talking square yards. We're talking a two-dimensional area. Again, if you need, write down area of a trapezoid formula. Write down area of a triangle formula. If I were to go into two-page mode, you could take a look and say, okay, how are all these problems similar? Well, perimeter, we have to add up all the lengths around the shape. Mind you that there are sometimes some numbers that are not needed for that perimeter, like on example 2 or example 3. Okay, what about the areas? For all the areas, you'll know the formula, substitute in the numbers, and calculate. Also think about units. Every one of these measurements should have units. Area will be square units, while perimeter is only one-dimensional, so we're talking inches, square inches, cubic inches, whatever the case might be. All right, folks, once again, whatever the assignment number, whatever the date, you'll have a worksheet today. Some of you might be able to show all your work on the sheet. Others of you, it'll put it into your notebook. Take care. Do well. Let's grow.